Welcome YouTubers to another episode in my Grammar Hero series. In today's video, I'm going to show you the solutions to the Mathematics Knowledge Practice Test from my website. In case this is your first time finding my channel, I do want to mention that I recently created a website called mastertheasvab.com. There, in addition to taking several practice tests, you'll also find resources that should help you as you prepare to take the ASVAB. All that said, let's go ahead and get started with today's video. Question 1 says if 6x minus 3y equals 30 and 4x equals 2 minus y, find x plus y. So at first glance, this looks like a difficult problem, and it is. We have, let me go ahead and write this off to the side so we can have some room to work with. We have 6x minus 3y equals 30. And instead of writing this as 4x equals 2 minus y, I'm actually going to put this in the same form as this equation. And to do that, I'm going to add y to both sides, which will give me this 4x plus y equals 2. So with this one rewritten to match this one, we can go ahead and place it over here. And as it turns out, the way you have to solve this one is by recognizing that this is a system of equations. And in Algebra 1, you probably learned some basic techniques by which you can solve these problems. More often than not, what you want to do is find something you can multiply one of these equations by, add it to the other equation to solve for one of these variables. In this case, I can see that if I multiply this bottom equation by 3, that will make this positive 3y. And when I add that to negative 3y, that variable y is going to go away, and I can solve this problem accordingly. So let's go ahead and do that. I'm just going to copy this one down here again. And as I just said, I'm going to multiply everything in this bottom equation by 3. So I'm going to multiply 4x by 3, y by 3, and 2 by 3. And then I'm going to add that to this equation to eliminate the variable y. Okay? So 3 times 4x is 12x. 3 times y, of course, is positive 3y. And 3 times 2 is 6. Now we're just going to add these equations. 6x plus 12x is 18x. Negative 3y plus 3y just goes away. 36 plus 6 is, 30 plus 6 is 36. Now we're going to solve for x. We can see our y has gone away. Divide both sides by 18 to get x by itself. This crosses out. We're left with x equals 18 over 36, which is just 2. Now, this problem asks us to find x plus y. We know what x is, but to solve this one fully, we need to figure out what our y is going to be. To do that, we take this x and we plug it into either one of the original equations and solve for y accordingly. So let's do that off to the side here. 6, again, that's x. We know x is 2, so let's plug that in. Minus 3y equals 30. Okay, 6 times 2 is 12, minus 3y equals 30. Subtract 12 from both sides. This crosses out. We're left with negative 3 y equals 30 minus 12 is 18. Divide both sides by negative 3. This crosses out. We're left with y equals 18 divided by negative 3, which is negative 6. So now we know what our x and y are. Again, x is 2, y is negative 3. Let's plug those in accordingly. 2 minus 6. 2 minus 6 is negative 4, which is this answer choice right there. You may see problems on the ASVAB that require you to be able to solve systems of equations, very basic ones, in which case you do have to rely on some very basic algebra skills to eliminate one of the variables. If you've taken linear algebra, you could have also put these two equations in matrix form and solved accordingly. But again, that's for people who have more of a math background, so I'm not going to discuss that in this video. I prefer doing it with matrices. They're just easier to deal with, but algebra is fine too. Alright, number 2 says the three angles of a triangle are 3x, x plus 10, and 2x minus 40. Find the measure of the smallest angle in the triangle. Okay, so we have some triangle, and we know one angle is 3x, another angle is x plus 10, and another one is 2x minus 40. What we need to know is that all angles, that is angle 1 plus angle 2 plus angle 3, all three angles in a triangle always add up to 180 degrees. Okay, so in light of that, we can say 3x plus x plus 10 plus 2x minus 40 equals 180 degrees. Now we're going to, of course, solve for x, or try to. Let's go ahead and combine like terms. We have 3x, x, and 2x, so that's 6x. And then we have 10 and negative 40, so that's negative 30 equals 180. Let's go ahead and move this 30 to the other side by adding it to both sides before we continue. We're left with 6x, 30 minus 30 plus 30 cancels out. 180 plus 30 is 210. Again, 180, 190, 200, 210. Now we're going to divide both sides by 6 to get x by itself. And we're left with x equals 210 divided by 6, which is, let's go ahead and work this out doing long division. 6 goes into 2, it doesn't, it's too small. 6 goes into 21 3 times without going over. 6 times 3 is 18. We subtract 21 minus 18, 18, 19, 20, 21. 3, we drop down this 0. 6 goes into 35 times. 6 times 5 is 30, so we can see that we don't have a remainder. So we know x is equal to 35. And in light of that, we can figure out what all of these other angles are by plugging in x accordingly. 35 plus 10, and let me do a new triangle. Let me just do this up here. X plus 10. We know x is 35, so this is 35 plus 10. So we know this is 45. The next one, and this, we'll call this one angle 1. Doesn't matter how we label them, as long as we figure out which one's the smallest angle. Let's call this one angle 2. It's 3x, and we got 3 times 35. Work that off to the side if you need to. 35 times 3. 5 times 3 is 15. Carry the 1. 3 times 3 is 9, plus 1 is 10. So we know this is 105 degrees. And finally, angle 3 is 2x minus 40. Again, x is 35, so we know it's going to be 35 times 2 minus 40. 35 times 2 is 70 minus 40. 70 minus 40 is, of course, 30. So now that we see what all these angles are, we see that the smallest of them is 30 degrees. And with that, we can answer this question. All right, so question 3 is in regard to a right triangle. It says a right triangle has a hypotenuse of 30 inches and a first leg of 18 inches. What is the length of its second leg? So we have some right triangle that looks like this. We're told its hypotenuse, which is always directly across from the right angle, so it's this length right here, measures 30 inches. Whereas one of its legs measures 18 inches. We want to find out what the measure of the other leg is. So in order to do that, we're going to have to use the Pythagorean theorem, which is a squared plus b squared equals c squared, where a and b refer to the legs of a right triangle and c refers to the hypotenuse of the right triangle. Let's go ahead and plug things in since we're given some of this information. We know the hypotenuse is 30, and we know that one of the legs is 18. So we'll go ahead and try to find the other leg. 30 squared, well, 3 squared is 9, therefore 30 squared is 900. We don't have to do too much work to figure that one out. 18 squared is the same as 18 times 18. You may want to work this one out if you don't know your squares up to 18, which I don't, so there's no shame in working it out. 8 times 8 is 64. Carry the 6. 8 times 1 is 8 plus 6 is 14. Start add a 0 since we're starting this number. 1 times 8 is 8. 1 times 1 is 1. 4 plus 0 is 4. 4 plus 8, 8, 9, 10, 11, 12. Carry the 1. So we can see that this is going to be 324. Okay, let's go ahead and continue solving for b squared in this case. To do that, the next thing I'm going to do is subtract 324 from both sides. This crosses out. I'm left with b squared equals 900 minus 324. Let's go ahead and do this. We can't do 0 minus 4. We can't do 0 minus 2, so we're going to have to borrow. This is going to become 8. This is going to become 10. And borrow one more time. This is going to become 9. This is going to become 10. 10 minus 4 is 6. 9 minus 2 is 7. And 8 minus 3 is 5. So now we have to say, now we know b squared equals 576. So to find b, we're going to take the square root of both sides. In so doing, this crosses out. We're left with b equals the square root of 576. At this point, I'd look at my answer choices to figure this one out, because I know 40 times 40 is 1600, which is too big. So that means this one's too big. 20 times 20 is 400, so I know this one's too small. Therefore, the only logical answer choice is 24. That said, if you wanted to confirm that, you can do 24 times 24. 4 times 4 is 16, carry the 1. 2 times 4 is 8, plus 1 is 9, add a 0 since we're starting this number. 2 times 4 is 8, 2 times 2 is 4, 0 plus 6 is 6, 9 plus 8 is 17, carry the 1, 576. Okay? So that's that one. Again, one of the formulas you should commit to memory is the Pythagorean theorem. You will use that on the ASVAB. That's almost a guarantee. All right. So this problem deals with square roots, just like the last problem. The number of digits in the square root of 648,025 is, so we got 600,000, 648,025. We want to know what the square root of this is. It's not as hard as you think, because think about it. Again, a lot of people get tripped up on these problems because they're saying, well, how am I supposed to figure this out? I don't know the square root of this big number. Well, what would the square root of 64 be? We would know that would be 8, right? Well, let's go ahead and pretend that this was asking you what the square root of 640,000 was. Makes it a little easier, and this is going to have the same digits as this one. So if we can do this one mentally, we should be able to solve this problem. So let's say we thought it was 80. Let's go ahead and work it out. 80 times 80, 0 times 0 is 0. 0 times 8 is 0. Drop down to 0 since we're starting this number. 0 times 8 is 0. 8 times 8 is 64. We can see that this would get us 6,400, not 640,000. So we know this is too small. Let's go ahead and step that up one more to do 800 times 800, because we know this is going to be 8 something, because 64, square root of 64 is 8, therefore the square root of 640,000 is going to be 8 something. We have to figure out how many zeros is going to be in this answer, So let's try 800. 0 times 0 is 0, 0 times 0 is 0, 8 times 0 is 0, 0 times 0 is 0, 0 times 0 is 0, 0 times 8 is 0. And since we started here, we have to add an extra 0. Now since we're starting this third one, we have to add 2 zeros. 8 times 0 is 0, 8 times 0 is 0, 8 times 8 is 64. Let's add. 0 plus 0 is 0, 0, 0, 0, 0, 64, 1, 2, 3. So we can see that the square root of this is 800, which is 3 digits. Therefore, I know the square root of this is going to contain 3 digits. Okay, so this was a critical thinking problem. It didn't require too much math. You just had to be able to say, well, the square root of 64 is 8. Therefore, I know this is pretty close to 64. Let me use that as a anchor point to solve this problem using logic. So that's how you do that one. Alright, number 5 says find the circumference of a circle whose diameter measures 10 inches. Use 3.14 for pi. So we have some circle. The diameter is the full width of the circle, and we know that that full width is 10. We also need to know the circumference formula to figure this one out. It's pi times diameter. So we know the diameter. We're told to use 3.14 for pi. As it stands, we have everything we need to solve this one. Again, we're going to let pi equals 3.14. Diameter's 10. So let's keep working this one out. Whenever you multiply something by 10, 100, 1,000, and so on, you simply shift the decimal according to how many zeros there are. There's 1 0 there. So to solve this one using mental math, I'm just going to take this decimal, shift it one time. So 3.14 times 10 is just 31.4. Therefore, we know the circumference is 31.4. Again, you may have noticed that whenever possible on this test, you have to try to use some mental math to speed yourself up. And in addition, if you have a good handle on mental math, you're going to make fewer mistakes, because you're always asking yourself if an answer that you chose was reasonable or not. Okay? When 36 is divided by 0.018, the quotient is, so this one's basically asking us to do long division. 36 divided by 0.018. Again, we know 18 goes into 36 2 times. So if we're using mental math to guide our work, we're saying to ourselves, this has to start with a 2, and all of these do. Now we have to know how to deal with long division involving decimals to move forward. The way you deal with decimal long division in this case is, since the decimal place is outside the division bracket, you have to shift this 1 to 3 times to make 0.018 a whole number, namely 18. And when you shift that decimal place on the outside of the division bracket, you have to shift it inside the division bracket correspondingly. So the decimal place is here. We're going to shift it 1, 2, 3 times. So we basically rewrote this problem to make it to get rid of the decimals. So we have 18 and 36000. Now we can apply some mental math to do this one. 18 goes into 36 2. Just bring up those zeros. Again, I just brought those up. So we're done. 18 times 2,000 is 36,000 with no remainder. Again, the key to this problem is being able to work with decimals and long division. All right, number 7 says a test showed that 10 out of 100 gadgets are defective. If a random sample of 2 gadgets are chosen, the probability that both are defective is. So in this case, we do have to know some basic probability. First, you want to know that the probability of anything is going to be between 0 and 1, meaning that, and let me go ahead and do that. Meaning that if it's 0, this has no likelihood of occurring. If it's 1, it means it's absolutely going to occur. So our probability is always going to be between 0 and 1. In this case, we're choosing 2 gadgets. So to find our probability, we're going to multiply these 2 scenarios together. The odds of the first gadget being defective is 10 out of 100, as it tells us right here. And then we're going to multiply that by the odds that the second gadget was defective. And if you think about it, the way probability works is, it says the first gadget you picked, it assumes the worst case scenario. So it says that first gadget you picked was defective. So that means there are 9 more defective gadgets in the random sample, and since there are 9 left, we know we lost one here too. Okay. Now, to do this a little easier, now that we set it up, we can reduce. 10 goes into 10 one time, 10 goes into 100 10 times, 9 goes into 9 one time, 9 goes into 99 11 times. Now we're just multiplying fractions, and to multiply fractions we just multiply straight across. 1 times 1 is 1, 10 times 11 is 110. So the probability of both of these gadgets being defective is 1 over 110. Okay? And in the formula sheet on my website, I think there's like 4 or 5 pages on how to find probability, including this scenario. So take a look at that. Again, probability is very simple. Basically, you have to know some assumptions when dealing with probability. Like right here, I assume that the first one we picked was defective to set up my equation. But once you get those assumptions down, which are very basic, probability should be pretty easy for you. Okay? But that was this one. Alright, so we have a square, which looks like that. We're told that the area of a square is 100, the length of its diagonal is approximately. Well, if you cut a square in half with a diagonal, you should notice that you have 1, 2 right triangles. And as we know already, the Pythagorean theorem, which finds this diagonal, which is across from the right angle, is a squared plus b squared equals c squared. Okay? Now, we also need to know that the area of a square is length times width. In this case, we're told the area is 100. And in squares, we know this side is the same as this side. And again, area of a square is not length times width. Let me erase that. Area of a square is just s squared. Okay? You take one side squared because all the sides in a square are equal. Okay? So area equals s squared. That's for a square. So we know 100 equals s squared. To solve for s, we're going to take the square root of both sides. This crosses out the square root. We're left with the square root of 100, which is 10. Therefore, we know all the sides of this square are 10. Okay? And again, we're going to work with one of these right triangles that we see in there and the Pythagorean theorem now to solve this question. Again, this is 10, this is 10, and we're trying to find that diagonal. So let's go ahead and plug things in. This side's 10, this side's 10 equals c squared. This is 100 plus 100 equals c squared. This 200 equals c squared. Let's take the square root of both sides. This crosses out. We're left with c equals the square root of 200. Okay? Now this isn't an easy one to do right off the bat because 200 is not going to be an even number. That said, we can use our mental math knowledge to figure this one out. 12 squared is 144. 13 squared is 169. 15 squared is 225. 14 squared, I always forget this one, so I have to work it out. 4 times 4 is 16. I believe it's 196. But carry the 1. 4 times 1 is 4, plus 1 is 5. Add a 0 since we're starting this number. 4 times 1 is 4. 1 times 1 is 1. Yep, that's 196. So therefore, I know the square root of 200 is going to be, this is going to be 14 point something, which we're going to let be just 14. Okay, so that's how you do that one. Alright, some basic algebra here. Again, when we're dealing with multiplication, subtraction, and everything jumbled together, we have to know that the order in which we work out these problems is governed by PEMDAS. That is, we do parentheses first, exponents next, multiplication and division from left to right, addition and subtraction from left to right. In looking at this problem, we can see we have multiplication here and here. So we know there's no parentheses, there's no exponents. There is multiplication, which we need to take care of first. So we got negative 2 times 2 minus 4 times negative 2 equals. So let's take care of that multiplication. Negative 2 times 2 is negative 4. We're not touching the subtraction yet because we're not there yet. 4 times negative 2 is negative 8. Okay, now that's gone. There's no division. And now we just have subtraction left. We have negative 4 minus negative 8. We can't do a negative negative. This becomes positive. So this becomes negative 4 plus 8, which is just 4. Okay? So that's that one. And I think there's going to be another one of those coming up soon. Number 10 says a rectangle is cut in half to create two squares that each has an area of 25. What is the perimeter of the original rectangle? So we got some rectangle that looks like this. It's cut in half to make two squares, each of which has an area of 25. As we saw in the previous problem, the area of a square is s squared. We're told that the area of the squares is 25 each. So 25 equals s squared. Take the square root of both sides. S equals just 5. So we know the measurements of all these squares, of the sides of the squares: 5, 5, 5, 5, 5, and 5. Now the question is, what is the perimeter of the rectangle? Again, the perimeter of a rectangle is width plus length plus length. Okay, let's see if we have those. Again, the width is 5. The length is 5 plus 5, 10. The width is 5, and the length is 10. So we do have all those. 5 plus 5 plus 10 plus 10. 5 plus 5 is 10. 10 plus 10 is 20. 20 plus 10 is 30, which is right there. Okay, so that's that one. Again, just testing your knowledge of area and perimeter, very basic shapes. Nothing too difficult there. All right, number 11 says, what is the value of the expression 26 minus 7 times 3 plus 5 divided by 4 plus 2. Whenever you have problems that are jumbled up like this, you should realize, first of all, that the way you work out these problems is going to be governed by PEMDAS, which is the order of operations. To remember this, of course, you go, please excuse my dear Aunt Sally. And this says that you work out these problems by doing what's in parentheses first, exponents next, multiplication and division from left to right, and addition and subtraction from left to right. That is to say, multiplication and division are considered equals, as are addition and subtraction. So let's go ahead and give ourselves some room, because it's very easy to make some mistakes on these problems. Okay, so with that copied, let's try to identify what we have to do first. Right here I can see we have parentheses, so we're going to go ahead and work on parentheses first. 26 minus 7. 3 plus 5 is 8, divided by 4 plus 2. And you'll notice that I focus on one of these operations at a time. So I just did parentheses. There's no more parentheses here. As I look through this expression, I don't see any exponents, so there's nothing to do there. Now we're looking for multiplication and division from left to right. I do have multiplication right here and division here. Since I'm working from left to right, I'm going to go ahead and do 7 times 8 first. 7 times 8 is 56. Again, divided by 4 plus 2. So I just did multiplication. So I look through, there's no more multiplication, but there is division. So let's go ahead and work on that. We got 26 minus 56 divided by 4 is 4 goes into 5 one time without going over. 4 times 1 is 4. 5 minus 4 is 1. Drop down this 6. 4 goes into 16 4 times without going over. 4 times 4 is 16 with no remainder. So 56 divided by 4 is 14 plus 2. So multiplication and division are taken care of. Now we're doing addition and subtraction, albeit from left to right. So we do have subtraction and addition. So let's work on the subtraction first, since we're going from left to right. 26 minus 14 is 12. Again, we're dropping down that plus 2. Subtraction's done. Addition, 12 plus 2 is 14. So that's that problem. Okay, so we've had 2 problems requiring you to use PEMDAS. All right, number 12 says, which of these fractions is the largest? Again, the way you view, you have to understand that fractions are, all fractions can be written as decimals and vice versa by doing long division. But right off the bat, I know 1/4 is 25%. Okay. And similarly, I know 2/5 is, I think it's 20%, but in case you didn't know, again, all fractions can be converted to decimals by doing long division. 2 divided by 5 looks like this. Again, you ask ourselves, how many times does 5 go into 2? It doesn't. We have to add a 0. By adding that 0, we bring up a decimal. How many times does 5 go into 20? That's 4 times without going over. 5 times 4 is 20. We subtract. So we know 2/5 is 40%. Sorry about that. I said 20. These practice tests do take a lot out of me, as I'm sure they do for you. So I do make some small mental mistakes here and there. 3/8. Let's go ahead and work on that one. But clearly, we should know right now that this is going to be bigger than all of these. But I'm just doing this for practice, because in general, they're not going to be this easy to do. So let's go ahead and do 3 divided by 8, which is 3 divided by 8. 8 goes into 3, it doesn't, it's too small, we have to add a 0. When we add that 0, we have to add a decimal. 8 goes into 30 3 times, so I know this is 30 something percent. Let's go ahead and do 7 divided by 8 for 7/8. 8 doesn't go into 7, so I have to add a 0. By adding that 0, I have to add a decimal. 8 goes into 78 times, so I know this is 80 something percent, which, as we can see, is the largest of them. Okay, so again, all fractions can be written as decimal via long division, and once you get the decimal, you can easily convert that to percent. Okay, so that was that one. All right, so number 13 says express 40% as a fraction in simplest form. All percents can be written as fractions by placing them over 100. So 40% is the same as 40 over 100. We can cross out this 0. This gives us 4 tenths. We can divide top and bottom by a factor of 2. Common factor of 2. 4 divided by 2 is 2. 10 divided by 2 is 5, which we can see right there. In the last problem, we just worked out 2 divided by 5, which got you 40%. So in this case, we went from a percent to a fraction. So we just did, in those two problems, both of those operations, which is a pretty good example. All right, so 14 says the total length of string to mark off a rectangular area that is 46 by 34 feet is. So again, we're dealing with a string marking off a rectangular area that's 46 feet long by 34 feet wide. And again, this string just runs outside the area. So in this case, we're going to be dealing with the perimeter of a rectangle, which is length plus width, which is 46 plus 46 plus 34 plus 34. Okay, let's go ahead and work this out to the side. 46, 34, 34. 6 plus 6 is 12, plus 4 is 16, plus 4 is 20. Let me just double check my math. 12, 16, 20. Okay, good. 4 plus 4 is 8. 3 plus 3 is 6. 8 plus 2 is 10, so this is 16. So we know the perimeter is 160 feet. That said, our answer is given in yards, so we have to convert from feet to yards, in which case we have to know that there are 3 feet in every yard. So we're going to take this 160 and divide it by 3 to find out how many yards this is equal to. 3 goes into 1, it doesn't, it's too small. 3 goes into 16 5 times without going over. 5 times 3, of course, is 15. We subtract. 16 minus 15 is 1. We drop down this 0. 3 goes into 10 3 times without going over. 3 times 3 is 9. We subtract. 10 minus 9 is 1. This is our remainder, so we can go ahead and put this over 3. So this would be 53 1/3 yards. Okay, which is right there. So that's that one. Getting a lot of ads for Kaiser University. I don't know if that means anything. All right, number 15 says, what is the simple interest on $500 at 9% for 2 years? So one of the formulas you should know for the ASVAB is I equals P RT, where I refers to interest, P refers to the principal, R refers to the rate, and T stands for time. This is the formula to find simple interest. So let's go ahead and plug things in accordingly. We're trying to figure out what the interest is going to be. Principal is the amount you invest, so that's going to be $500. Rate is always the percentage given. Instead of writing 9%, we're going to write this as 0.09. And T is in years, so we know this is our T. So we'll just go ahead and put that in the formula accordingly. Okay. I like to cheat by doing mental math, as you may have noticed. So I'm going to do 500 times 2, which is 1,000. And this is going to be times 0.09, of course. Now remember what I said earlier. When you multiply anything by 10, 100, or 1,000, you just take the decimal place and shift it according to how many zeros there are in the number. So in 1,000, there are 3 zeros. So we're going to take 0.09 and shift it 1, 2, 3 times to make 0.09 just 90. So to answer this problem, the amount of interest that this investment earns would be $90. Okay? All right, number 16 says Andy's job is to attach a ladder to a water tank. The water tank is a 20-foot wide cylinder and has a volume of 9,420 cubic feet. If the length of the ladder is equal to the height of the water tank, how long is the ladder? So let's do a little sketch here. That's not a good one for this problem. Because we know we're dealing with a circular water tank, so I kind of want to get this pretty good to see. There we go. Okay, so we're dealing with a cylinder that's, again, it's 20 feet wide, and we don't know how tall it is, but we're told that the ladder is basically going to connect to the height of the cylinder. And we also know its volume. So to do this problem, we know we're dealing with volume of a right cylinder, which is this formula: volume equals pi r squared times height. Of course, pi r squared is the formula to find the area of a circle. So we just take the area of the circle and multiply it by its height. Again, we were given the diameter. We need the radius. The radius is always half the diameter. So if that's 20, the radius is 10. So this volume becomes pi, radius is 10. 10 squared times height. We're also given the volume, so let's go ahead and plug that in. 9,420 equals pi 10 squared times height. And again, this one doesn't, it says use 3.14 for pi. So let's go ahead and work that out. 10 squared is 100, as we know. H is just the height. We don't know that yet. Before I go any further, I'm going to use that little trick I showed you in a couple problems. Again, any decimal multiplied by 10, 100, or 1,000, just shift the decimal to the right according to how many zeros there are. There's 2 zeros in 100, so 3.14 times 100 is 314 times height, so we got rid of that. Now we're trying to solve the height, so we're going to do divide both sides by 314. This crosses out. Again, this is over 314. Now this is where the fun starts, because we're doing long division. 9,420 divided by 314. This will get us our height, which is what we're after. And this isn't as bad as you think. Imagine this. Imagine I asked you to do this. You would, of course, say this is 3. 9 divided by 3 is 3. Well, we're going to use that logic to solve this one. Because imagine if this was 309,000. You would say, of course, well, let's cross out 2 zeros here. This is this. 3 goes into 90. What is that? 30 times. So I know that this right here is going to be approximately 30. Okay? So looking at my answer choices, I know this isn't right, and I know this isn't right. I know this is a possibility, and this is a possibility. But that said, all these answer choices are even. So instead of doing this long division, I'm just going to take 314, multiply it by one of these to see what gets me 9,420. Once I figure that out, I'm done. So let's do 314 times 30. 4 times 0 is 0. 1 times 0 is 0. 3 times 0 is 0. Drop down to 0 since we're starting this number. 4 times 3 is 12. Carry the 1. 3 times 1 is 3, plus 1 is 4. 3 times 3 is 9. Let's add. 0 plus 0 is 0. 0 plus 2 is 2. 0 plus 4 is 4. 9 plus nothing is 9. So I know that this answer, of course, is 30. So I know the height has to be 30 feet. Okay, so that's it for this practice test. I hope you found it helpful. As always, I encourage you to subscribe to my channel, as well as leave feedback in the comments section below. If you get a chance, check out my website, mastertheasvab.com. I have a lot of resources that are available for you for free. And of course, if you really feel as if you're benefiting from this content, you can always send a donation via PayPal to me. Links are in the description of this video as well as on my website. But all that said, and on that note, I'm going to go ahead and cut you loose. Konnichiwa.